Hello, everyone. Good evening, Asia. Good morning, USA. Good afternoon, Europe. Hope you guys are having lunch and are having fun. This is Daniel, and I am here in the Moralis live stream. I want you to say hi to our moderator, Birdie. She's going to be with us in this show to actually just answer your questions that you guys might have regarding the hackathon. And she's much more involved in the actual organization of the hackathon itself than myself. I'm just the coding robot. So let's get on to it. I would like to know how many people we have in the chat or joining the stream right now. If you guys are there, I would love to have a shout out and let me know where you are joining from and who you are. If not, we just start immediately. Do talk about our subject today. And if you guys are aware of this, the title of our workshop today is Web3 social media. And this is something that I think is very relevant and timely. And I think you guys are going to enjoy. We prepared a video a couple of weeks ago where myself and other members of the team, we put together a boilerplate for Web3 social media. I'm not a front-end developer, so that was in React, which is not actually my cup of tea, but that came out very, very nicely. And conceptually, this is a subject that I feel it's very interesting, and I wanted to introduce you guys to that concept today. So what our workshop is going to be about is about this topic, and we are going to talk first about the elephants in the room. And these are questions that you guys have been asking in the forum that is even making sense to have decentralized social media. Does it even work? Is it something that we want to do? And if we want to do it, why? So that's some elephants in the room that we are going to tackle first. Then there's specifically why this Web3 social media might be important. That's the second topic. The other one is why Moralis, and this is going to be an interesting story on how this project started of the social media Web3 boilerplate. Then we're going to talk about the project, which is the contract that underpins this boilerplate, and how it started as a thought experiment with me and a couple of buddies of mine. And then we talk about the contract itself. We are going to close going back to revisit the boilerplate and how you work with it. But I think that part is mostly covered in our video. So if you guys want to take a look on that, I will encourage you to go to the video and check it out there, because that's a lot more in detail. There is 1 hour and 47 minutes of content in that video. So it's a lot of topics there that for a live recording session, it's much more suitable to have it in the longer format video than in this workshop. So let's start. And I want to start with the elephants in the room. And the elephants in the room are the following. Let's go to the first slides. The elephants in the room regarding Web3 social media are sustainability, viability, and accountability. And what a hell we mean by that, right? So obviously the first one is sustainability. And sustainability means, does it worth it to have decentralized social media where we have these very intensive, energy intensive processes to maintain the blockchain? That's a question that a lot of people have been wondering on in our video, and that a lot of people have posted questions there regarding this specific topic. And well, the answer to this is that proof of work, which is the one that is very intensive, is not the only consensus mechanism that you can have in the blockchain. So it's a very suitable to have this kind of like a transaction intensive applications such as social media in a blockchain that doesn't use proof of work and that is able to manage more throughput. And there are solutions for that, and that kind of goes beyond the specific subject of this workshop, but there is an answer for that topic of sustainability, which we as an industry care a lot. We have the other elephant, which is viability. And this has to do with the fact that paying for each interaction with a social media platform is not very viable for a lot of people, right? Do we really want to have people having to pay or post tokens when you interact with a blockchain, right? Or when you interact with a dapp? So this is a little bit more complicated to answer than the fact of sustainability. And then the answer there on that one is that actually the tokens that you are paying to whatever protocol is keeping this social media dapp going not necessarily have to be earned by financial means or by buying them, right? You can have some sort of application where you earn those tokens because you are interacting with the platform, right? And we have several projects right now that like the BAT, the basic attention token, that is earned by you giving attention to something, right? So yeah, you might need tokens to interact with Web3 social media in the future, but those tokens might not necessarily be money. Those might be earned in other ways. So that's the topic, the second elephant. And the third elephant in the room is accountability. And this is, I think, the most important aspect of this. And this is the part where Web3 social media kind of outcompetes the traditional social media. When you are in Facebook, when you are in Twitter, when you are in any other platform, you are basically trusting this platform with your data and with all your relationships and your network as an individual. With Web3 social media, you could just keep that information and bring it with you to any platform that you are using. So in accountability, I think Web3 social media shines. In viability is very important to keep it in the way that you are going to earn the tokens, because this demo of the Ethereum decentralized boilerplate obviously is an EVM blockchain where the tokens are earned with very traditional means, but that's not necessarily the case, right? This is just a proof of concept. And sustainability, that's something that we as an industry, we are taken care of. I want to take a time to say hi to everyone. So we have Kresimir from our team join from Croatia. We have someone from LA, Malik, which it's very early for him. So thank you very much for joining, man. And we have someone very special. I would like to give a shout out to I missed your message, man, in the chat. Where are you? TP 5 star from Chicago. Wow, that's very early for you as well, TP. Thank you for joining. I remember TP because he has been asking very interesting questions in the video and also in the forum. He interacted a lot with this project. So I wanted to give him a shout out. Thank you very much for all your participation in this specific project, TP. And then we have someone joining from Nepal. That's more close in Asia. And we have people from Africa. We have people from Australia. We have Zenith from North Africa, which is also quite early for you. No, it's not that early for you. It's noon. And we have people from down under in Australia. So after tackling the elephants in the room, then let's go from the other perspective that we want to check at this. We have someone from India, from Belgium, should join now. And let's get to why Web3 social media. So basically, these are 3 points that are, I think, are very important and why this might be very interesting. We have a social media where the influence of people doesn't come from the depth of the pocket of the people. And that's something important, right? How do you get clout in social media right now? Well, you can be very funny and you can be very interesting. And you can also buy a lot of ads and you can buy a lot of Twitter followers as well. And that might give you some clout, which is actually fake, but it depends on how much money you have. So it's not very organic. Though obviously there are a lot of people that has a big following that it's organic, but that's actually not the only way to earn clout in the traditional social media that we have right now. The other point, and this is related to the previous point, is that this would be a social media free of bots. And I wouldn't say that it's impossible for bots to appear, but we can design algorithms inside the Web3 space that will actually make the bots irrelevant. And when we go to check the decentralized contract, we are going to really get to the point on how we can make this happen, how we can build an algorithm that will make bots irrelevant. Then the other point is that we can have a social media where your influence depends on how valuable your input is to a given community. So if you are valuable for the community, you are going to get more clout. If you are not very valuable, basically you are not going to have a lot of clout. And we have more people jumping out. We have Omar Herrera, my cousin. Well, not actually my cousin, but we have the same surname, from Detroit. And we have Johnny Renton. And we have a crypto lover from the UK. And Code with Joe. I love that name. So let's get on why Moralis was ideal for this POC. Well, this contract, when you see the actual social media, the contract of the Decentraland that we use for the boilerplate, it's very intensive in two things. You need to have fast and reliable sync of contract events because it's basically broadcasting whatever is happening in the contract regarding the creation of content and the creation of posts and the voting. All of that is relying mostly on events. So you need to be very fast in indexing and syncing those contract events. And the other point, and I think this is the most salient point, is that with the current blockchain infrastructure that we have, it is impossible to manage social media 100% on chain. That will be crazy. If you check how much gas you will spend in storing a variable size string in Solidity and run that in an EVM, that's not viable. So you have to have some way to have the data that it's also decentralized but it's not on chain, and that's the reason we use IPFS. And Moralis has this very nice characteristic where you have a server where you are able to sync all your contract events very easily and index the blockchain very in a very lightning like speed. And also you have an API that offers you very convenient integration with IPFS, where Moralis is also offering you some gateway to access IPFS data. So if you are building a front end for the contract of the Centradit, then Moralis is the ideal place to have it, because you are going to do more work in making it uh, more nice to interact with, and you are going to invest a lot more time in that part and not trying to manage the manual configuration with APFS and the syncing of events. Buenos dias, Argentina, Horacio. And we have also Zenith asking, well, never understood how IPFS works. Well, in a nutshell, how IPFS works is that if you have used BitTorrent before, it's a little bit similar to that. So there are little chunks of data in all the people that has participation in that network. And then those chunks of data are consolidated together by gateways that can serve the entire file or the entire content in bytes to whatever client is consuming it. So if you can, it's very similar. The easiest way to understand it, though is not apples to apples comparison, is that it's very similar to BitTorrent. And if you have used BitTorrent before for educational purposes, you know how that works. So let's move to the next topic. And this is a little bit on the history on how the Centradit, which is the contract that we use for the boilerplate, was born. So I was having a conversation with some buddies of mine here in Taipei with regarding blockchain, and we were in a boot camp that was organized by the Taiwanese government. So long story short, but we were a bunch of nerds, basically talking to each other. And one of the people in the workshop, in the boot camp, my buddy Everett, he was thinking about how we could use the blockchain to build a social media that allow people to gain reputation organically. Meaning that if you are posting about health, you are actually an expert on health. If you are posting about finances, you are not just a guy that basically is living in his basement and kind of like just pulling some very interesting narrative to make people following him, and maybe giving people bad financial advice, but he's not actually an expert on finance. But he will gain clout just because of his popularity and because he's fun, or because he's telling people that they are going to get rich. So how we avoid those scenarios? Can we use the blockchain for that? And then the other point that we wanted to, and we were developing this thought experiment with, was how can we use blockchain to build also a level playing field, right? Is even if you are an expert already, you will need the community to validate you organically to have a high reputation and be able to have this high clout in the community and be more trustworthy. So it's not something that comes from authority. It's not a process like that, but it's much more organic. But also validates the actual experts. The other point was what we were talking before, how we make the bots irrelevant. And that is basically the three points that we wanted to solve with a thought experiment. After going over this, we realized that there are two basic aspects that you need to manage to make this happen. You need to manage the reputation and you need to manage the categories. And these are linked. So your reputation should not be the same for every topic that you post, because maybe you are a great guy on finance, but you have no saying or you have no expertise in healthcare, for example. Or maybe you are an authority on ancient Egypt, but that doesn't mean that you're an authority in programming. So this is a little bit something to try to solve something that happened in Reddit, for example, where your karma can be very high, but it's not linked to a category. And thank you, very nice, TP, very, very kind of you, very, very kind of you. So well, basically that's the thing, right? So how we're going to link this reputation with the categories and how we're going to do it organically. So that was the thought experiment, how to solve it. And this is the part that starts to getting how I started designing the Decentralit project with the input from my buddies. And we decided to take a page from Google's book. And this is something that happened in the back of a handkerchief when we were having lunch. And I will explain to you what these nice smiley faces are. But if you can pick something from here, is that you can pick that the size of each of the smileys, it's proportional to the number of smileys that are pointed to it. So you can see here our friend, the blue one, has these five green ones, six green ones pointing at him. So he is bigger. He's pointing back to one of them, so that one got bigger because all the other ones don't have anyone pointed to them right now. Then you have the red one that is being pointed by the yellow one, so that's what make him quite big, though he only has one people pointing to him. And that's it, right? So if you see it from here, you can appreciate that the way that if you think in the size of the ball and as the reputation is like, you get reputation from the respect that you get from other people, but that other people is getting their own reputation from the respect that are getting from other people, right? So that's kind of the ideal. That's kind of like what Google started doing in their search engine back in the day in the 90s. Right now they have improved this algorithm and they have added a bunch of things, but this is basically the way it used to work. So we're taking a page from Google and kind of like making it happen this way. But there is a problem with this, and the problem with this is that it is linear. And in the next page you are going to understand what I mean by linear. And basically, in a nutshell, the reason this is linear is because doesn't matter how many people is pointed at you, the amount your reputation grows by their support is linear to the amount of people that is basically liking you or stuff like that, right? So this makes this kind of system for Google, it worked perfectly, but for this kind of social media, it's gonna make it possible to be gamed by bots. Because then what you can have is you can create a bunch of bot accounts or fake accounts and make all of those fake accounts like your post. And your reputation in this model increases every time someone likes your post and decreases every time someone dislikes your post. But what happens if someone has just on a lot of fake accounts under its control? So then the system just comes down. and it basically has the same problems that the actual social media that we have, the traditional legacy social media. So how do we solve that? And the way that we are solving that is with this specific solution. And bear with me, guys, this actually makes a lot of sense, but I know like just looking at these graphs makes you think on derivatives and calculus, and that's PTSD for a lot of us. So but bear with me, it's actually very easy to understand. So what is happening in the Decentraland is that instead of having this graphic where if I get one like in my post, my reputation increases by 1, we are having another type of growth scenario where the reputation of the people that is liking my post is making my reputation increase, but in a logarithmic way. So the graph looks a little bit like this. The properties that this gives to the contract are quite interesting. It means that for someone to add 1 point of reputation to you, they need to have basically this is the limit. So the way I designed it is that they can have zero within 0 to 2 of their reputations. But if they have, yeah, TP, bear with me. This is quite easy, actually. So basically, what it means is if you are thinking in purely the normal logarithms, is that if someone has 0 or 1 of reputation, they couldn't add any reputation to you because that is not the way the graph works. So we just hack it. And then let's start by this point. So if someone with 0 reputation or with less 2 or less of reputation likes one of your posts, your reputation increased by 1. So that's it, right? But if they want to add 2 to your reputation every time they like your post, their reputation will need to be 4. If they want to add 3 to your reputation, their reputation will have to be 8. If they want to add 4 to your reputation, their reputation will have to be 16. If they want to add 5 to your reputation, their reputation will have to be 32. If they want to add 6 to your reputation, their reputation will have to be 64. So what this system makes is that it smooth out this kind of a situation where a lot of people can, when a lot of fake accounts can be controlled by one person, and that person can make its reputation grow very fast, kind of exponentially or directly, because if they control a lot of accounts, then basically this function is going to become very, very exponential. But it kind of reduces that because it makes it logarithmic. So in order for you to have someone to add a lot of reputation to you, that person has to have already a lot of reputation. So that's controlling a lot of bots. And if we take into account that each bot will cost a token, that we are not thinking about money, but a token that you have to earn somehow, then it's going to make it very difficult for someone to control that amount of bots. So this function actually makes those bots irrelevant in this social network. And if I have to describe the decentralized contract salient feature, is this. This is the core of it. And let's go to the contract elements. So the contract is actually quite easy to understand. It's a very simple contract where you can create posts and comments. And the way that you create posts and comments is by creating content that is stored in IPFS. And then that content has to belong to one category. And then every time someone likes your content, your reputation increases. And every time someone dislikes your content, which is a post or comment, your reputation decreases. So what the contract has to manage is actually very simple. And that's basically the contract, right? So we're going to go to look at the specific code of the contract a little bit later on. And we are going to get to understand some parts that I have been receiving some questions right now. And one of the questions that someone asked, which was very interesting, is how do you make comments? And this makes a lot of sense because in the video and in the boilerplate, we have not implemented comments. You can only post once, and that post will get likes or dislikes, but you cannot comment on that post. So the contract of Decentraland actually supports the comments. It's just that that feature is not implemented in the boilerplate to make the boilerplate a little bit easier to understand and have it out a little bit earlier. But it's actually very easy. In the contract per se, each post or comment is exactly the same object, is content. And the only difference between a post and a comment is that a post has a post ID that by convention you can define that a post ID of a certain hash is basically means that that post doesn't have any parent post. And if it is a comment, that means that it has a parent post, and the parent and the ID of that parent post will identify the comment. So that's the way you implement the comment. So basically, they are the same objects. Then the categories are very easy as well. It's just a string that is paired to an ID, and the reputation, which is just a register, right? Like how much reputation you have in your address. So the contract, we're going to see it in detail later. And then let's move on to the next one, which is the boilerplate itself, right? And well, almost half an hour to only get to here. So that was the theoretical part. We are going to jump to the practical part right now. I will not stop a lot in the boilerplate. I will kind of like be more focused in the contracts and also in how to deploy the contracts, because this is something that you guys have been asking a lot. And it's something that was not included in the video of the boilerplate for one specific reason, and that reason is that people has quasi-religious convictions about what platform or what framework they like to use for smart contract development. I am Python developer at first. Well, when I started developing, it was Pascal. That will give you a little bit of a tip about my age. But yeah, it was Delphi and Pascal. But well, yeah, Python is the language that I enjoy the most, and a lot of people in crypto too. The guys at Corp Finance, Patrick Collins as well. I know a little bit of Java, and yeah, and JavaScript. But yeah, I'm a Python guy, right? By my taste, I like it, and because I have more practice on it, so I use Brownie. If I take in the video of the boilerplate and start to teach you Brownie, that will kind of steer you away from the core of the project, which was the decentralized project. And that's the reason I didn't cover that part in the video. I wouldn't cover that deployment part with Truffle because I'm not very used to Truffle, right? This is just not what I do in my regular development life, in my own projects or Moralis projects. Actually, when I work with projects in Moralis in the contracts, though I usually demo those in Remix, my development happens mostly in Python. This is a very interesting question, Houseful. How to create a smart contract without using Solidity and MetaMask and EVM machines? Wow, that's that's a good one, man. There are alternatives. There is a Stacks, which is a platform that supports smart contracts on Bitcoin, but it's kind of a layer 2. And you can use that one, and that doesn't use Solidity. They use their own um, their own type of language for smart contract development, and it's a layer 2 for Bitcoin, and it will work with the Bitcoin wallets, right? Not with MetaMask, and it will run in the Bitcoin system, not in EVM. So that will be an alternative. The other alternative would be Solana, which we have Jim the Reaper in our team that is a very huge fan of Solana. Sometimes we want to kill him because a lot of Solana content, man. We know it's good. We know. I know if Jim. I don't know if Jim is listening to me, but well. So yeah, Solana could be another option, right? There you can have smart contracts. You can write them in Rust, and it will be running not in the EVM, and you will be using Phantom, not MetaMask. So there are alternatives. If your question is regarding to what alternatives programming wise, those are kind of the alternatives. Now, if what you are asking is if there is some sort of no code technology for you to build smart contracts, that's a little bit more in its infancy right now. Actually, should I dox Ivan? No, I will not dox. No, basically, just as a premiere, we want to actually in Moralis, we want to make some actually some no code platforms to help do to help you to do some basic functionality without having to know a lot of code. But I don't know what is the progress on that. There's a lot of things in the pipeline. So in Moralis, there might be something for that. And Eric, as Eric is mentioning, Flow and Cardano have smart contract languages that are very, very interesting. Yeah, actually, Cardano has kind of like a drag and drop. That's a no code. That was the other one that I was about to mention. That if you don't feel comfortable with Solidity or coding, you could go to explore. Eric, you will correct me. I don't know if Plutus is the Cardano tool for no code development, or is there actual language that is derived from Haskell? Because if it's the drag and drop, that's going to be very easy for no code. But if it's the one that's derived from Haskell, then it's going to be difficult for newbies to wrap your head around that one. I love functional programming myself, but it's not the cup of tea of a lot of people, and it can get a little bit complex very, very fast. Yeah. Yeah, EVM has too many good points too. Yeah, I also agree, Johnny. I do agree a lot with that. The EVM, it's amazing. I like the flexibility that you get. You can do Avalanche, you can do Polygon, you can do Binance Smart Chain. Everything works. There's a lot of tooling. So yeah, I love it. If you ask me what do I like the most, I think because of the flexibility and the tooling that is available, I like EVM compatible blockchains, and that's where I rely. That's what I rely in my own personal projects outside of Moralis. Everything is EVM compatible. If you ask me what I like more as a curiosity, I have been toying around with Solana a bit in Rust because I feel that I need a low level language, and I think Rust is a very, 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 very cool. And then the other one that I like, I have been trying to research a little bit on Cardano as well, because I love Haskell and functional programming. Unfortunately, the documentation of the Cardano team is not as rich right now. It's very difficult to have a documentation that is as well developed as the EVM ecosystem. So that Cardano is a little bit in its infancy there. I wish they had more documentation, but it's good. So well, we kind of went into that forest for a long time. So let's go to the practical part. I do want to cover the contract and a little bit of the things. So let's get to the code of the contract. Birdie, I would appreciate your help here. to go to the practical part. Switching screens. Wait a minute, guys. We are switching the screen to the code. Great. So let's go to the smart to the code itself. What I have here, and I will just show you here from the beginning, is the Web3 social network boilerplate as it exists in the GitHub repository. So to get this one, you will just have to go to GitHub, and then in GitHub, you get the link to that repository. And then here in your VS Code or in your terminal, you just go git clone the link, and it will copy the entire structure of the code that I have here and the folders and everything. So let's start with the smart contracts. Those are in contracts and decentralized. Please ignore this truffle part. I kind of remove it already, but I don't know. Some might have updated and pushed it back. I kind of removed it because it got a couple of people confused because they thought that they could do truffle deployment of the decentralized just like this, and actually you cannot, because what the truffle folder that is here was just inherit from the plain vanilla boilerplate that this project is deriving from, that it's inheriting from that project. So this truffle basically just treated as a as something that should not be there. So don't ignore it, just ignore it completely. Not there. I will just get rid of it again and push it back, because that should not be here. And then just go to the centrality. So let's go to the contract. So let's get it on. And this is the Solidity version that we were using at that time, is the latest one. And it has an MIT license, which means that anyone could just use it, even for commercial use or whatever, right? This is totally free and open source, and this license means that. If you guys have seen this in other code or contracts, that's what it means. It's a very permissive, free and open source license. Read the license itself to know exactly what are the limitations, but this one is actually the most permissive license there is in the open source world. Now, let's go. Okay. Yeah. We're rebase the head of your branch. Yeah, I did that actually, and I pushed the changes. So I think what happens is that someone pushed it back because they thought that it should have been there. The post in the chat. Great. Wait a minute, Elio. I will post it there. So let me go here and Web3 social media boilerplate. Wait a minute. Here you go. Oops. I have the link, but I'm kind of new to this platform, so I don't know exactly how to post the comments, but I will try to send it to my colleague and she will get it. So here it is. This is the link. It's going to appear in the comments right now, and it's going to be in the chat. So let's continue. So in the code, basically we have, I will leave the events for the last, and let's start by these data structures here. So we have an struct, and an struct is kind of similar to an object, but it doesn't have methods. So you can think on an struct as a certain data structure, right? And this struct is called post, and it has the following data inside. You have an address which is the post owner. So the owner of a post is represented by his address. You have the parent post, which is a bytes 32, which is just a hash that we get. We have a content ID, which identifies the basically the index where we are going to go to look for this in IPFS later on. You have the votes that the post has, and you have the category ID, which is also a bytes 32. So if you are thinking mostly in database terms, basically the parent post is an ID, the content ID is an ID, the category ID is an ID, the post owner is also an ID because it's the address, and then basically only the votes are kind of like the naked data that is here in this struct. Now let's go to the mappings. The mappings are basically registers where you kind of build things that are similar to how to call it, like dictionaries or objects in JavaScript, dictionaries in Python, where you can map key value pairs basically. So the first mapping that we have here is the reputation registry that maps an address, and this address maps to another mapping which maps a bytes 32 and gets to an integer. And basically what this is saying is that you have your address, which is your primary key, and then you have a category. So this is a one-to-many relationship. Like you have one address, but you can have many categories where you have reputation, and then in all of each of those categories you will have a certain amount of reputation, right? So that's it. Then we got to the second one, which is the category registry, which is a map of bytes 32, which is just the ID of the category, to a string, which is basically the value of the category, right? Whatever category you have created. You have the content registry, which is the ID of the content, to the actual IPFS hash where you can find the content. So this is a little bit, the string just contains the category itself. This just contains a pointer where you have to fetch data in IPFS. Then you have the post registry, where you have the registry of all the posts. And that maps to our little struct here. So basically you have an index, which is a bytes 32, and that will map to this struct that we have over here. And the last one, you have the vote registry, where you basically just get a registry to know if someone has already voted for one post or not. And this is because of the characteristics of the social network that we're building. We don't want to allow people that have already voted for a post to like it again or dislike it again. So you can do it, but you have to do it from a different address. So that's basically the data of the contract. Now we go to the functions, and the functions are rather simple. So for creating a post, you have to submit a parent ID of the post. You have to submit a string, which is the content URI. That's basically the URI of the content that you're creating, and the category ID. What this will do is that you will record who is the owner that is creating this post, and it will put it in this variable owner. We will get this content ID by just hashing the content jury that you are passing on. And this is basically, this content jury is just a hash that is usable in IPFS. So first, you have to process everything to IPFS. When you have that hash, you can call this create post, and that's the way that the component is working in the underlying React app or in whatever client you want to build. So this should be that URI that is pointing to the IPFS object. So we're hashing it, and that becomes our content ID. Then we have the post ID, which is a hash of who is the owner, the parent ID of the post, and the content ID. And that's the ID of the post. And we hash it, and that becomes that. Then we just populate in the content registry this content that we are creating with its content ID. We populate in the post registry all the information that belongs to this struct over here, and we are adding that to the post ID. So that will be this mapping over here that we're mapping a vice32, which is this post ID with post struct, all the data that we have here. And then we emit two events. One is that we created content, and then the other one is that we created a post. In the content, we are going to broadcast the content ID and the content jury. And the post ID, in the post created, we're going to do the post ID, the owner, the parent ID, the content ID, which is very important, and the category ID. These are broadcast by these events that we created here. And the idea is that to be able to index our social network, the clients will need to go to index these events from the blockchain, and they will get the data. That's much cheaper than storing the data on the blockchain itself, because a post could be huge, right? This way, we just have everything in IPFS. We are just working with hashes, and it just works. Then we have this functionality here, which is for botting up or botting down. And what this does is just basically changing the value of the votes of the posts here, and adding one to them, because the upvotes in the post just add linearly. But when you do that, you also are adding reputation, right? And this is the part that is interesting, because it has to do with what we were talking before regarding the logarithmic function that I showed you in the PPT. We have a function here that we call validate reputation change, where you submit how much reputation you are adding or removing, and the category ID and the sender. And basically is just verifying what is the reputation of the sender in that specific category. And then it's playing with the formulas that I showed you before. If the sender has a reputation that is less than 2, the reputation added, no matter what the caller of the contract is calling or sending here, will be always equal to 1, and that's it. If the reputation, basically, no, it's not that. Sorry, I have not checked this code in a while. Sorry, my bad. No, what is happening is that if the reputation of the sender in that category is less than 2, and he's adding more, he's adding any reputation amount that is not 1, this is going to return false, and that means that he's not going to be able to vote up or vote down. He can only add or remove 1 because his reputation is only 2. So that's what it is doing. In the other case, where his reputation is greater or equal than 2, then our logarithmic function is kicking in. Yeah, TP, you're right. Exactly. You have to stack the types together in the struct to save gas. The reason I didn't do it was because I think I was a little bit wanted to make it a little bit simpler, and I wanted to avoid kind of like having this idea to do that. The other part is that, and this is the most important part on why these are not kind of packed variables. And I will explain that right now, just for UTP. So right now I remember, sorry, I have been away from this project. The reason is the following. The EVM works in isolated units of 32 bits. that's 32 bytes. That's the way it works. So it doesn't really matter if you are working with less or more. That doesn't really matter regularly, right? What you mean, what you are saying is that you could pack those values in the stroke in order to save gas, and that's true. If you have some values here, usually that works pretty well for integers or unsigned integers. You could play in a way that you group them together so they add up to those 32 bits, and then you are going to save gas because the EVM will kind of pack them together. No, the reason I didn't pack the variables here is because the address is already a bytes 32. So there is nothing more there than I can do, right? That's going to be bytes 32, and the stroke is not going to save me any space there. I cannot have an address that is less than bytes 32 on length. That's just the nature of the type. It's already a bytes 32. Then with the parent content post and the category ID, all of these, because they are hashes that I'm getting with these kekek functions, those are bytes 32 as well. So also I cannot save anything there, right? So I just get this int that I'm just getting here like a 40, and this will save me gas when I'm kind of like processing, and that's true. So that's the reason I leave it like that. But in the way that it's working with these other variables in the stroke is not gonna is I have no way to pair it with another one, so it will add up to the 32 because the other ones are already 32 themselves, right? There's no way to pack it already because all the other ones don't have a space to pack anything. So I hope that answers your question. If not, feel free to drop in the forum, but that's kind of what is happening there. Sorry for the digress there. And there's another issue that will happen here. And here, to some people, this verification here, which is just the verification of our logarithmic function, that's the way that we are checking that this person actually is not trying to add more reputation than the logarithm base 2 of his own reputation. And it's through this verification we are multiplying, we are raising 2 to the power of his own reputation, and that has to be less or equal to the reputation that he's adding. And the idea of his own reputation, sorry. And the idea here is to confirm that logarithmic function. Now, the reason there are some warnings that might appear there to some people, because this function here might overflow because this is the reputation added is just a uint 8, and this result of this operation will get a uint 8 as default. So there's a little bit of an overflow checking that it could be added here to make that warning disappear, and that will make it work. So that's the way it works. So this is kind of the idea of this function. So basically, the bot up or bot down is just adding the reputation that you want to add and adding 1 point to the post, but validating that we are keeping in the constraint of our logarithmic function. And this is a little hack actually to make the logarithm work in Solidity, because that's a little bit complex if you try to do it with logarithms actually. So I kind of go to the opposite operation, which is the exponentiation. Then we have here to add category, to get content, get category, get reputation, which are just views, and get post, which is just to view it. So that's it. I will share another window right now to just Johnny, sorry, man. Yeah. Yeah, that's Yeah, that could happen. I have not checked that. I have not QA that part, Johnny. So I don't remember. We tried to validate that in the client, in the boilerplate. Everything gets validated before it gets sent to the contract, but I might have not validated that one. And that overflow, I didn't actually add the validation in the contract either. So that's some contribution to the project that you can do. So let's go to the deployment, basically, which is the last part that I will cover today. For the rest, I will invite you guys to go to the video. So let's go to a share screen. I will stop this current screen and I will share another screen right now. Share screen, and we are going to share a Brave tab. And let me just get this one, remix. So we have remix here. So let me go to share my screen right now. Let's get share remix, share it. And here we have remix. So amazing. You mean YouTube? Okay, thank you, John. Overflowed. Okay, I see. So let's do the following. So let's say that we have this remix here, and I will press this button here, which will allow me to just upload any document there in remix. So I will go to my documents. I kind of forgot, where do I have this thing? It's not in the load, it's not in document, so we'll have to go up. Documents iCloud, no. Okay, no, we do, it's gonna be faster to have the old copy paste. So I will have the centradit here. And now that we have it there, we're going to copy paste the contract here. So you just bring it to Remix. This is the fastest way to deploy, guys. Like, if you need a fast deployment for any of our projects, do it in Remix. That way you don't have to do anything regarding truffle or brownie or get with the zealots that everyone is in the Web3. Just use Remix for testing and not very complex projects. Just use Remix. So Taya Concom, mainnet fork is one mainnet? No, mainnet fork is not equal to mainnet. What you do with a mainnet fork is that, for example, in Ganache, what it will do is that you could take a snapshot of the mainnet in the specific moment, and it will be a copy basically that you can use for testing, and you interact with it. The only problem with that approach is that you have to have some Ether or whatever native token of the mainnet that you're using to actually use the mainnet fork, right? Because it's gonna get copy and it's gonna get copy in your machine, but the assets are gonna be the ones that are still there, right? So I tend to not use it because they are testnets, and unless there's a very specific reason to use it, I don't really like to use mainnet forks. But yeah, that's the way you use them. Okay, so let's do the deployment. So to deploy in Remix is very easy. So you just have your contract is copy. Then you go here in the second icon, and that icon has this icon over here. No, this icon over here, and you just compile it. And it is compiled. Then you go to the other one and you can deploy it, right? No, the question that a lot of people ask me is, how do I deploy it, right? Like, if I deploy it from here, it's going to give me this thing here that is JavaScript VM London, which is a local JavaScript kind of emulation of the EVM, but is not in an actual testnet that I can integrate with Moralis very easily. So the way to do it, to deploy in Moralis but have it in an actual testnet, is actually quite simple. You just go to injected Web3, and then this pops up, which is your MetaMask. I will connect right now. So I have it here. And you connect. And here in your MetaMask, you are going to see this connected. Right now, here I'm in Fuji, which is the testnet of Avalanche. And I added this one by, obviously, by using the Moralis speedy node service, which is the most reliable and faster node that I could find for this specific testnet. And that's the case for a lot of the testnets. And to check that out, you can go to settings and networks. And here you can add whatever network you want using the speedy node that you get from Moralis. You can see it here, right? Like this, I got from my Moralis server. And if you don't know how to do that, basically just go to moralis.io, you register, and the speedy nodes are very easy to find. Now, let's go back to this thing. So here I am in injected Web3. This is my account. And here I could just deploy this decentralized contract. There is no weird constructor or anything here, so I can just deploy. It is asking me this, so I can just confirm. Will ask me if I actually want to deploy, so I confirm here. And if you notice, everything is happening in my MetaMask through the Moralis speedy node. And here I have my contract, right? So it's already deployed. And here I have the decentralized. So I get an interface also to create the categories, which is another part that was difficult for some people. So I can create in my new contract, I can create a category called marketing. Of course, I will have to spend some testing AVAX for that. And here I have it. So I created marketing. I can create another category called Bitcoin, for example. And I add the category here. And here we are. So as you see, that's kind of like the idea of how that works in the deployment. I think it's a little bit late for some people. I guess you guys have to go to work, and I have to go to take care of the baby by orders of my wife. So we are going to have to leave it there. But this is actually what I wanted to cover, guys. I wanted to cover the part that is not covered in very detail in the video, because it's a huge video actually, but just the client and all the React application code, that takes a lot of time. So I left the deployment of the contract out because the reasons that I kind of explained to you. But this is the part that I did cover in this workshop, and how to do it very easily, just copy pasting your code in the browser, and you create your categories there. And once you have created your categories, you can just follow with the video. And that's it, guys. If you have any questions, go to the Moralis forum. And if you have any questions about the hackathon, reach to Verdi, reach to the forum as well, reach to the Discord. And I really appreciate your attention. It has been a lot of fun. Thank you very much. And follow our videos and subscribe to our YouTube channel. I have some spoilers for you. DeFi intro is coming. I'm preparing a DeFi introduction that is going to cover flash loans, and is going to cover putting liquidity into a liquidity pool in Aave, everything in Avalanche Fuji. So follow us, subscribe, and see you there. Thank you, guys. Bye-bye.